This is Stephen Mullins, Instructional Professor of Meteorology here at the University of Florida. I'm recording this very late, 10 p.m. on Sunday, November 6th. This is the last month of hurricane season, but that does still mean that it is hurricane season. And currently we have our eye on this big old area of thunderstorms that is north of the Puerto Rico and Dominican Republic area and east of the Bahamas. And we're expecting this area to come up, consolidate, and make a path westward to impact the northern Bahamas and somewhere on the Florida coast, as well as having impacts throughout Georgia and into South Carolina before it potentially turns to the northeast. But right now, this definitely does not look like anything that might resemble tropical or a strong hurricane. Right now, the National Hurricane Center has dubbed this 98L, and they've identified the center of the surface circulation somewhere about where I just placed that X, and where this new tower of convection has just formed just to the north of it. But what we see is that from this center of circulation, the strongest storms is very far to the north and east of this area. There are some showers to the southwest, and all of this makes for a very large, broad area of circulation that is not exactly a tight circle, but is more of an oval. And even more than that, we have the problem that this features a horseshoe, if you will, of very humid air in the light gray area, but also a interlocking horseshoe of dry air that is coming in from the southwest. And so this whole area is dealing with thunderstorms, but also dry area, or dry air that are interlocking its way and complicating its current ability to be organized. If we look over at the European Center's deterministic model, this is the forecast for essentially right now. We see a circulation in the wind barbs, and we see it being elongated with a little bit of a northeast to southwest axis to this. Now, right now, this whole area is basically the only game in town feature-wise. We have a jet stream going through the plains and up to the northeastern United States. There's a blob of vorticity out here in the Gulf of Mexico, but really the main steering for everything at this level, at the midway up the atmosphere, is this area of thunderstorms and the circulation around it. However, comparing this area to what's going on closer to the surface, if we go from 500 millibars to 700 millibars and move this back to the same date and time, what we see is once again a circulation that is elongated northeast to southwest, but this elongation extends a little bit more to the northeast, and we see in the colors here the most concentrated area of spin being on the northeastern lobe of this elongated oval circulation here. And the same thing is true if we go even closer to the surface. So this is 850 millibars, where the colors showing the circulation as well as this height field shows the circulation up towards this end. But if you look at the wind barbs, there's still this big old oval of circulation throughout this area. So these aren't exactly aligned on top of each other between closer to the surface and midway up the atmosphere, and the location of the highest area of spin or vorticity aren't exactly on top of each other either. The other complicating factor moving forward, besides not exactly knowing what the structure of this storm is that as we move forward, the fact that this large circulation area isn't an exact circle, and there are vorticity blobs on various sides of this, mean that you have vorticity blobs rotating around each other. Here, just to stop, is one on the south, one on the northeast, one on the northwest, and exactly how all of this works out starts to affect when one of these vorticity blobs becomes a little bit more organized. gets brought into the center of the circulation and becomes the primary storm that we start to talk about as it heads toward the northern Bahamas and into Florida. So that complicates everything. The other thing, as we are even trying to form this storm, is if we look at moisture. Here's the look right now showing those interlocking horseshoes of very humid air and very dry air. And as we move forward, this storm basically struggles with dry air the entire time, just as it's trying to get rid of this dry air that's moving north from the south over on its east side. It really only stays in a humid environment for just a little bit, and now once again we're dealing with dry air all over again. Move forward in time, maybe it's shedding the dry air. Oh, it's dealing with dry air on its south side again. So we're going in and out of times where the center of circulation is in a pocket of humidity and moist air, and then other times where it's dealing with dry air going into the center of circulation. So this seems like an inhibitor, at least on the ECMWF model here, of this storm developing, and by the time it makes landfall, we really aren't looking at much of a strong system at all. Going over to the GFS forecast, we see a similar story playing out. Here's the look right about now. We have that strong vorticity blob with a very elongated circulation northeast to southwest. This has even 500 millibars that blob over on the northeast, but as we move forward, once again, we have this large area of circulation with various vorticity blobs on various sides of this, and all of that has to get worked out before one of those areas becomes stronger, wrapped into the middle of the storm, and then how does that continue to play out as we head toward the northern Bahamas and into Florida. Now, this system, when we start looking at moisture, once again, we have our dry air, still dealing with dry air, move forward. Now we've got a pocket of moisture. Looks like this storm, as it heads over the Bahamas and into Florida, stays within a pocket of moisture. It doesn't deal with the dry air at this last minute, and so we have an intensifying storm heading into Florida. And if this were to verify, we would have a much stronger storm here. Now, with both of these storms, when it's making landfall, it looks like any sort of rain isn't going to go too far away from the storm, but is primarily going to be on the north side as far as rain is concerned, maybe up to the Florida border. But after the storm comes inland into Florida, it will then stall and make a turn toward the northeast, and during that time, we see the moisture depicted here on the GFS coming into the Carolinas a lot more. Get out of that. And so all of this rain, while it's coming into the Florida Panhandle, starts to impact the Carolinas prior to the storm heading toward the northeast, and then only after the storm ejects off to the northeast and into the Atlantic do we have the rain ending. Now, the rain is only one part of the story here. Exactly what the impacts are, in some sense, doesn't matter how strong the storm is going to be, because we're not expecting a extremely high-end situation here. If we look at the surface winds, this is on the stronger GFS forecast. What we're seeing as this storm starts to make its turn and approach the northern Bahamas is an extremely strong pressure gradient on the north side here between the low and then a high pressure area up in the mid-Atlantic states. So because we have this very strong pressure gradient, and we have all this area depicted in green of tropical storm force winds, that for a couple of days is looking at bringing these really strong winds into the Carolinas, Georgia, and Florida coastlines to the north side of the center of circulation. So as we move this inland, this is fairly consistent that yes, on this particular run where the wind or where the storm is very strong, yeah, we still have the strongest winds right by the storm, but this is a very large area north of the storm to have very strong winds here. And if you're going to have strong winds, you're going to be bringing big waves as well. So this is the significant wave height out over the ocean. And as this storm is approaching the Bahamas and the Florida coast, we're seeing a large area here in the reds and into the purples, where the reds are showing 15-foot waves and the purples are showing 20-foot waves out over the ocean. Now, it's not very simple to say what waves out over the ocean exactly means for surge, but just to say if all of this wave energy is heading inward towards the coast, and not just of Florida right near where landfall might occur, but also up through northern Florida, through Jacksonville, into Georgia and the Carolinas, and we'll be doing this for the day or two into landfall. And not only that, but once the storm has gone into Florida and starts to make its turn, now we have even more wave energy heading at the Carolinas as the storm departs off to the northeast. This wave impact and potential storm surge, beach erosion, etc. Impact is going to be something to watch, especially if in the future this storm starts to become a little bit stronger than it is currently forecasted to get. And the other issue as far as impacts is just where this storm is going to be and when it makes impact. This current look is from the ECMWF set of forecast tracks. This is Tuesday night going into Wednesday morning, or this is now Wednesday midnight going into Wednesday morning. And so we have a group of ensemble solutions here for the low, with some members that are going to be slower and some members that are going to be faster. And these are all moving about the same speed and about the same direction. But again, some are faster, some are slower. So the question is, when does this make landfall? And where the storm is north versus south depends on, or starts to control, which areas of the coastline sees all of that wind and waves that we just saw to the north side of the low. So the fastest storms seem to be making impact in southern Florida here on Wednesday afternoon. But then as we go off, this is now Thursday afternoon, and some of the slowest members haven't gotten there yet. Not only that, we see some of the members, once they've made it, some of the fastest members, that they've made it across Florida and into the Gulf. By this time on Thursday afternoon, we're starting to see all of these members start to curve north and eventually want to take off to the northeast, because we have a trough in the jet stream that is entering the plains off the picture here. Well, if these are turning, some of these have again gone through and are starting to turn in the Gulf of Mexico, but some of these are turning to the east off the east coast. And in fact, as we play this forward, some of these never exactly make landfall, whereas some of these are way off on the other side. So where the low is, if it's off the east coast, if it's over central Florida, or if it's out into the Gulf, this is going to impact the later rain and wind and waves impact that we see from this storm as we move into next weekend. In fact, as we play this forward, we get some of these ensemble members start to jet off to the northwest, where some of the members that perhaps were the fastest to make it across Florida, have curved off to the northeast, but kind of get left behind as we play this forward, that some of these are out of here and some of these are still hanging around. So talk about different impacts by the time that we get to the end of next weekend here. All of this will get sorted out as we figure out more about this storm tomorrow. There are 7 Hurricane Hunter flights that are expected to go out tomorrow. About half of those in the low levels, and A couple of those are going to fly at really high levels, dropping those dropsondes through essentially the entire troposphere all the way down to the surface. So we ought to get a much better look at the environment tomorrow, and also we'll see some of this development tomorrow in order to resolve what's going on in the mid-levels and those issues with the rotating vorticity blobs just going all around each other. So there's a lot to work out between now and then, and as always, keep paying attention to the National Hurricane Center, the weather forecast offices of the National Weather Service, and eventually we'll start to potentially even needing to pay attention to your local emergency management to do anything regarding evacuations. That's it for now. Thanks for watching.